Yes, hello. This is a little section over 10.5. Shouldn't take terribly long, I hope. I have to get my annotations set up. Okay. So rationalize the denominator. In this section, usually we have some denominators that are one term, and then sometimes we also have some that are binomial. But in this case, for this semester, we're just going to cover the ones with the one term in the denominator. But for it, a radical to be simplified, no radical in the denominator, okay? So let's look at what we need to do. This is not an equation, so you can't just do whatever you want. Whenever you have an equation, you can do certain things. As long as you do it to one, you do it to all. When you have just an expression, we have to be a little more careful. So for example, some people would say, well, I'm just gonna square the denominator to bring that 6 out, and then I'll just square the numerator. But let's look at this, you know, if just to prove that that's impossible. So let's say we have this fraction of 3/10, and if you use that reasoning and you tell me, well, I'm just gonna square this, and then whatever I do here, so you get a 9/100. Do you agree that 3 out of 10 on a pie, for example, in a piece of pie is the same as 9 out of 100? This does not work. So you can't do that. So since we're not allowed to do that, what else can we do? We need for the radical sign to disappear. Now remember this, the nth root of a to the n is a, meaning the radical sign disappears if my exponent matches my index. So in this first one, for example, and I'll do several, but if you took this and you took it times another radical with a 6, would that not lead you to a square root of 6 squared or a square root of 36, because you can then use the product rule? And then would that not lead then for that radical to disappear and you just end up with a 6? The one thing you have to watch though, this is an expression. Whatever you do downstairs, you have to do upstairs. So you have to multiply this by square root of 6 as well, because then you're essentially just multiplying this term by 1, and that is completely legal. Square root of 6 over square root of 6 is a 1, right? So that's completely legal. That's like you not changing anything. So the numerator then is the square root of 7 times 6 is 42, and nothing changes. There's nothing going to come out because the 6 is a 2 times 3, so nothing comes out of there. So this would be then your final answer. They're the same expression. This one is, the denominator has a radical in it, so we're going to rationalize it, meaning turn it into a rational number, okay? So this denominator is rational. That's why it's called rationalize. Okay, so let me do another one. Rationalize the denominator. So before you put a final answer in, you have to check and make sure it doesn't have a radical in the bottom. This technically has a radical in the bottom because this is technically a square root of 9 over a square root of x, which is then really, if I wanted to go ahead and simplify the numerator, it'd be a 3 over a square root of x. But I know that I cannot take the, that would not be simplified because it has a radical in the bottom. So what we're going to do is we're going to say, oh, how do I get that x out from under? My index right now is a 2. If you don't see it, it's a 2. And my exponent is just a 1. But so if I make this into another x like this, then that would lead me where I need to be, which is the denominator like this, which then leads to the denominator being a simple x. So, but for you to be mathematically correct, you gotta multiply the numerator by the same thing, right? Because that's then essentially this, is that multiplying everything times 1, meaning it doesn't matter. So what are you left with in the numerator then? You have a 3 square root of x, 3 square root of x. Okay, let's keep going. So that's just rationalize the denominator. And yes, assume that all variables represent positive real numbers. We're not going to worry about absolute values right now. So let's look at the next one. I'm trying to make this fairly quick. I'm probably not going to do every single one. Let me see what they look like. Oh, that's all we have. Okay. Well, then I think when we have that done, we'll have it covered. So this is a quick video, hopefully. I overanalyze and over-explain, but some of you, it really helps because then you fully understand what's going on. Okay, rationalize the denominator. Now you have some options, okay? So what I don't want you to do. So I'm gonna work over here for a minute, and I don't want you to write this down. But some students say, hey, you know what, I just need that times itself because it's, you know, that this is what they do. And then whatever you do here, you do here. The problem with this is then you're left with a square root of 45 squared x squared, which then leads to 45x. Don't write this down, I just want you to see it. And then my numerator is 2 times the square root of 45x. And then you might realize that, hey, 45 is 9 times 5. So this is going to turn into 2 times 9 is a 3 squared. This is the problem here. You'll see this in a second. 45 is 9 times 5. Okay, and then we would bring out the 3. And then we would have a square root of 5x left. And then you would turn around, you would have to, you can make that a 6, but you're going to realize that 45 and the 6 have something in common. And if 45 is a 3 times 15, do you see this? This would then cancel. So this is not the best way to do it. It's not illegal. It's just not something I would do. So what you want to do is maybe simplify the denominator first. And again, this chapter is difficult because there's just a lot of options. What if you simplify the denominator first? 3 squared times, so 9 times 5, you see? And then you would bring the 3 out. And now you have to say, I need to get rid of the radical. The only thing that's under the radical is the 5x. So I'm going to multiply the denominator times the square root of 5x. Whatever I do downstairs, I do upstairs. So that then I end up with three times, and then you have a 5 squared and an x squared, which leads you to 3 times 5 comes out, x comes out. But my numerator is then still 2 square root of 5x. 2 square root of 5x. And then my numerator is 2 square root of 5x. That has to stay under. And then 3 times 5 is 15x. Okay, so we can say, hey, you know what? This is exactly the same thing. It's just, if you do it the way I said, don't do it that way, it gets bigger than it should be, and then you have to cancel upstairs, downstairs. Where if you do the smallest thing you possibly need to bring out anything from the radical, you don't end up in the end from here to there. You do not have to worry about canceling anything upstairs, downstairs. They're already simplified. And be careful with this. This one here and this one here are not the same. One's a radical, so it's a square root of 5x, and one is just a 5x, so they are not, you know, you can't cancel stuff. like that. Okay, so let's do one more. Hopefully that'll clarify everything. Your goal is always get rid of the radical in the bottom. So yes, I could technically say I'm just going to multiply the bottom by square root of 18, but that's the same scenario as in the last one. I'm not going to do it that way because I want to keep it small. So I'm going to split this up. And then I'm going to say square root of 18. 18 is 9 times 2. That turns into 3 comes out, 2 stays under. Now I need to get that 2 out from under. This is where now I have to multiply this by square root of 2 for that to become a square root of 2 squared. So then whatever I do downstairs, I have to do upstairs. And that leads me to upstairs would be, you know, the product rule still applies. If the index matches, you go under. So you have a square root of 5x times the square root of 2, so that's a square root of 10x. They're all under. And then on the bottom, you have a 3, and you have your square root of 2 squared, which causes 3 times the 2 comes out, right? So you end up with final answer, square root of 10x over 6. So if you ever want to check this stuff without worrying about the x right now, you could just say, as far as the decimal number, does the square root of 5 divided by 18 equal the square root of 10 divided by 6 without a radical? Okay, so that's all for 10.5. It's a pretty quick section. Thank you.